So we're going to look at a few more conditionals before we jump into this lab stuff. The example we looked at last week was the bank account balance example. I have my bank account balance. I set that equal to 400. I get an amount to withdraw from the user. They say, I want $50. I check to make sure the amount that I want to withdraw is not greater than the amount available in their bank account. If it is bigger, then I say insufficient funds. And I have my else case, which handles the regular path, where I subtract the amount they want to withdraw from their bank account balance, and then I print out on the last line here their balance. So remember that if this condition is true, then we run what's here. If it's false, we skip what's here and we go to the else, and we run what's in the else instead. So if it's true, I print insufficient funds, and then I skip the else case. If it's false, I skip the regular case and I go to the else and I run what's down there. But sometimes we have more conditions. It's not just this is true or that, or it's false, and I need a path for each of those. So an example would be if someone enters they want to withdraw a negative amount. In my code, I'm going to check if the amount I'm trying to withdraw is greater than my bank account balance. A negative amount won't be. So I'm going to let the user withdraw a negative amount, and if I subtract a negative amount from my bank account, they're going to go up. So if my user says I want to withdraw negative 100, I'm actually going to end up increasing their bank account balance. We don't want that. So instead I can check, say, if amount to withdraw is less than 0, can't withdraw a negative. So that's another check that we put in our code. But how do we handle all three cases? I'm going to give you guys a couple minutes, open up lab 3.1 and take a crack at this. So let's look at how we can do this. In my else case, I need another check. So just like my slide, I'm going to check if amount to withdraw is less than 0. That's how I know I shouldn't do the withdraw. So in that case, I tell the user that you cannot withdraw a negative amount. But that's not enough, because if I just write that, if I run this and type in -10, down here it says you cannot withdraw a negative amount, but then it withdraws the -10 anyway, and it gives me a balance of 410. So I need to put this code in here so that it doesn't run if amount to withdraw is negative. But how do I do that? I can use my if-else instead of just an if. So if I put an else around this, and I run this and I type in -10, now I get you cannot withdraw a negative amount and your balance is still 400. So the layers of indentation here, the levels of indentation, really help you understand, or they should help you understand what code is contained by what. We have a bank balance of 400. The user types in, I want to withdraw 1,000. It hits line 12. Amount to withdraw is greater than bank account balance. If the user entered 1,000, is 1,000 greater than 400? So the user says, I want to withdraw $1,000 and hits enter. That's going to go into amount to withdraw. Then I'm going to say, is amount to withdraw greater than bank account balance? My balance is 400. I want to withdraw 1,000. Is 1,000 greater than 400? True or false? It is true, because 1,000 is bigger than 400. So since this is true, then we go to line 13 and we print insufficient funds, and then we skip this entire next block, the whole else case, because everything inside of this else only runs if this condition was false. Now let's take the other path. The user says I want to withdraw $50. So we come down here, we have amount to withdraw is 50. I say, is 50 greater than 400? True or false? False. And then we come down to line 14, so we're going to skip this line 13. We're going to come down to the else case. Then we're going to say, is amount to withdraw less than 0? I said 50. Is 50 less than 0? False. So then we skip line 16 right here, and we go down to this guy's else case. I print withdrawing 50, and then bank account balance minus equals 50, and then I'm at the end of this. So then I just come down here and print the result. Now our last case is the negative amount. So I say I want to withdraw $10. Line 12. Is -10 greater than 400? False. -10 is not greater than 400. So that's false. So then we go to line 14. Then we go to line 15. We're in the else case now. If amount to withdraw is less than 0, is -10 less than 0? True or false? True. So we go to line 16 and we print, you cannot withdraw a negative amount. Then we skip these two lines because they're in the else case. So because this was true, we only ran line 16, not lines 18 or 19. We jump over that, and then we're at the end and we can print out the updated balance, which actually wasn't changed. And that is how you can check multiple conditions. So you might have one condition you start with, in this case, whether or not you're asking for too much, then another condition that you check. But this is kind of ugly, not the easiest to follow. We have a better way. Else if. Else if is a structure we use to check multiple conditions. So I want to print something that says either good morning, good afternoon, or good night, depending on what time of day it is. Say hour equals, and then let's say it's 10 for now. So I have the three conditions. Let's say either it's less than 12 and it's the morning. Let's just define night as after 6 p.m. So it's less than 12 morning, less than 18 or 6 p.m. We'll say evening, and then anything else we'll say evening. So we'll say morning, afternoon, evening. So our first condition is going to be if hour is less than 12, I'm going to print good morning. Now I have an else case for this, but instead of having an else and then putting another if inside of it, I'm just going to say else, and then the next condition I want to check here. So else, if the hour is less than 18, system.out.println, good. And then I have a final else case on the end that checks nothing. Good morning, good afternoon, and good night. So the hour is set to 10 here. So when I run this code, it's going to go to line 4. Is hour less than 12? True or false? True. So we print good morning, and then we skip everything else. Now I'm going to change my hour to 20. So now the way this works, we go to line 4, we say hour less than 12, true or false? Hour less than 18, true or false? Okay, so we end up in the else case. There's no other if here, so it's just else, and we run that. Good night. If I change my hour to 16, is hour less than 12, true or false? Is hour less than 18, true or false? True. So I print that. Good afternoon. Only one of these 3 lines will run. There's no way to get more than one. And it does these in the order you list them. Notice that here, I don't have to check again to say, is hour greater than or equal to 12 and less than 18? Because if I'm looking at line 6 at all, that means that the check on line 4 must be false. We never would have checked down here. We never would have come down here at all if we executed this code. So it's going to walk through these conditions one at a time until it finds a true one. Once it hits a true one, it's done. It does whatever's in that block and it exits. Now watch carefully, class. I'm going to change 12 up here to an 18. I'm going to change 18 to 12. And then I'm going to switch these two. So if hour is less than 18, I print good afternoon. If hour is less than 12, I print good morning. I say it's 16. I get good afternoon as I expect. Let's say I change this to 10. What do I want this to print if hour is 10? I want it to print good morning, but it doesn't. It prints good afternoon. This is a very, very important point. It checks these one at a time. Whenever it hits the first one that's true, it just executes that code and then it's done checking everything else. So when I set my hour to 10 here, down here I say if hour is less than 18. 10 is less than 18. So it prints out good afternoon and then it just exits the whole thing. It doesn't look at all these conditions and figure out which is the best fit for it or anything like that. It starts at the top and it works its way down until it finds a match. So make sure the order here is right. If I want to go from like hot to cold, I would say, is it greater than 80 degrees? Is it greater than 70 degrees? Is it greater than 60 degrees? I can't do those in the opposite order because 90 degrees is greater than 60. So if I check for 60 first, then I'm done. Like here, if I check if hour is less than 20 first, then it doesn't matter if the bottom I check if hour is less than 10 because everything that's less than 10 is also less than 20. Here's that code with an evening and night. You can have as many of these as you want. This thing is sometimes referred to as an else if ladder because you kind of climb down the ladder until you find something that fits and then you do the code there. Let's try lab 3.1 again. I want you to look at the else ifs here. If you got to work with what you had before, good. That's harder than what you should have to do now. So I want you to restructure that to use else if. Instead of having another if inside of the else, you have 3 conditions. You have your bank account balance is too much, you have that it's less than 0, and then you have your else case, which is it's fine, withdraw the amount. Talked about not, so I don't think I have to talk about it too much. I'm applying it just to a Boolean. Up here I say if, not. Boolean have homework equals false. So if not have homework, then relax. Have homework is false, so not have homework is true. If I don't have homework, then relax. This is a more complicated one that is a pretty good example of something you should never do or would never do, but just to show you, you can have a not that inverts a complicated condition as well. You're not going to need to do anything like this on the lab for demo purposes. That should really be all you need for 3.2. And then for 3.3, you need to know how to compare strings. So in Java, equals equals works for comparing integers and booleans and all the things we call primitive type. It doesn't work for comparing objects. What's an object? We'll get to it. But it doesn't work for comparing strings. So for strings, you can't say if choice equals equals yes. This will compile and it will run, but it's just going to give you false like every time unless something kind of magical happens. I don't want to talk about it. You're going to get false. So this is saying print out to the user, continue, asking them to enter yes or no, and then it reads in their choice into a string. Now the intent here is if the user says yes, do something. But the right way to do this is string dot equals. This is how you compare strings. You have your first one, you say dot equals, and then you say the thing you want to compare it against. So choice dot equals parentheses quotes yes. So this is wrong, this is right. I'm just going to print out the results of this comparison. So if I run this, I type in yes over here, I would expect, since choice is equal to that next line, this to be true. Instead I get false. I run the opposite one where I have dot equals instead of the equals equals call. Now when I run this and I type in yes, I get true. And if I type in no, I get false. Comparing a string to another is dot equals. And for that last lab, I'm really just asking you to compare strings. You don't have to handle all the cases you handled in the first one. Lab 3.3 is just ask the user if they want to withdraw or deposit, not ask them if they want to withdraw, but make sure it's a positive amount that's less than and make sure the deposit is not a negative amount, etc., etc. Just checking string comparisons. It's just an exercise in string compare.